Hello everyone, today I'll be showing you a cool program I wrote that allows you to see the wave function and the amplitude of an electron in a box. First I'll show you the code. It's pretty simple. Basically you have four functions and a few values you have to define at the start. You start by defining pi because that's pretty useful. Then you have L, which is the length of the box, and you have two integers. The third one isn't necessary. I just had it for debugging or something. These have to be integers because obviously the electron energy levels have to be, integers, full numbers. This round val function is just to round the value to 3 decimal places. This was necessary because I want pure values. Okay, if we get into the first function, this calculates the wave function. We're given the energy level x, energy level y, length x and length y. The length x and length y are basically the places in the box, so the x and y values, and you feed this in and you get a z value, which we will be plotting. And basically you round and you calculate the sign of the energy level x times the length x divided by the length of the box. If length x is 0 or the length of the box, then this will equals 1, and if it equals 1, then 1 times pi, and given the energy level is 1, then this will be sine pi, which is 0, and then everything will equal 0. That's basically how it works. And then you have the same thing with the y, and it returns the wave. You could multiply this by 2 divided by L to get the accurate value, but I want to show it between 0 and 1 because it's better to visualize, so I have it like this. Next you calculate the amplitude. That's not very complicated, it's just wave times wave. And here we have the main function. Here you have to prompt the user for a value for n in x direction and a value for n in y direction. These two graph 2Ds or graphs are not necessary. The ones in the middle are the ones you need. This is the wave function 2 and amp2. The 2 is for 2-dimensional because I was doing it in 1 dimension before that. Here we have a loop, two for loops inside each other for the x and the y coordinate. Basically it goes through each row and gives it a y value, so basically you're going through the whole box. And the wave is just the wave function given these values, and you plot either in the wave function, you plot the wave function, and in the amplitude plot wave times wave. This function here isn't really needed, but it's there. And then you increment count by 1 because count is needed to plot these 2 points. Then you plot all the graph 2Ds, and for the wave function 2 graph 2D, you need to set the npx and npy, which is the bin count, to 100, or that's the value that I found was optimal, because what it was doing is, since the values at the edges are 0, but the ones at 1 and 2 are not 0, it was giving it a bit of a curve, and that wasn't very good. So to make it more accurate, I increased it. Thank you to the root forum members for pointing that out. And you just plot it normally and save it as a PNG, and that's pretty much it. I'll show you the program in action. Now let's just enter 1 and 1. And here we get the wave function and the amplitude. I'll have to change that title later, but it doesn't matter. As you can see, the edges are sort of flat, but you can still see the curve a bit. Not that big of a deal though. And here you can see the amplitude. I'll also show you an example with other values for nx and ny. Let's say 5 and 2. And here you can see those values. It's not completely flat on the edge, but it's pretty good for what it is. And yeah, that's about it. Thank you for your attention, and I'll see you in the next one.